You're probably already familiar with the rules of exponents. These are just shortcuts, really, for making math a little bit easier, believe it or not. So rules of exponents involve monomials and sometimes polynomials, but we're going to be using monomials today, which is just one term. It can include a number, a variable, or you can multiply together a number and a variable, like in these examples. 34xy means 34 times x times y. A little bit of vocabulary. When we have exponents, we also have a base. The base of this exponent is the 5. That's what number has the exponent on it. The actual exponent is the 2. And you know what that means. You know that it means we have 5 squared would be 5 times 5. 5 times itself 2 times. 5 to the third means 5 times itself 3 times. 5 times 5 times 5. So the first rule we're going to look at is the product of powers. So I have two powers up here, 5 to the second and 5 to the third. 5 to the second was 5 times 5. 5 to the third, 3 times. So if I multiply the two of those together, I've got 5 multiplied 5 times, because we have 1, 2, 3, 4, 5. 5 to the fifth. And notice 2 plus 3 equals 5. So the first rule is that if you have the same base, you have to have the same base. Here the base is A. And we're multiplying. This doesn't work if we're adding, only when we multiply. Then you add the exponents together, just like we did up here. 2 5s plus being multiplied plus 3 5s being multiplied means I have 5 5s being multiplied. So I'm going to do this example for you. Notice you have to distinguish between regular numbers and variables that have exponents. 7 and 2, regular numbers. So we're just going to multiply those. 7 times 2 is 14. We're done with those. Now I want to look at the y's. Y to the fifth. And this one, notice, is y without an exponent. If it doesn't have an exponent, that means it has an exponent of 1. So I have 5 plus 1. So I write the y with 6. Adding the 5 plus the 1, I get y to the 6th. Now I'm ready to look at the x's. I have x squared and x to the 4th. 2 plus 4 is 6, so I'm going to have x to the 6th. That's my answer. Now you try the other 3 in this section. The next rule we're going to look at is the quotient of powers, when we're dividing. Again, notice we have the same base. A is the base. We have exponents of m and n. The rule is there. Keep that same base A and then subtract the exponents. And that makes sense because if I had 5 to the third over 5 to the second. Well, 5 to the third is 5 times 5 times 5. 5 to the second, 5 times 5. Notice these two 5s make a 1. 5 divided by 5 is 1. These two 5s make a 1. So I'm only left with 1 5. And 3 minus 2 is 1. So we just subtract. I'm going to do this middle example here for you. 12 and 8 are regular numbers. So I just treat those like regular numbers. I look for whether I can divide them or can they reduce. And I notice that 4 goes into both of those. 12 divided by 4 is 3. 8 divided by 4 is 2. So I just reduce the 12 over the 8. I'm done with those. Now I'm going to look at the x's. I have x to the third over x to the first. Always put a 1 on those. If they don't have an exponent, it means it's a 1. So I'm going to subtract. 3 minus 1 is 2. It's a positive 2, so that means I have more x's on the top than the bottom, so my x's are going to be on the top. I've got 2 left over. If I have x to the third, x times x over x to the first, one of those cancels out and I have 2 left over on top. Now let's look at the y's. I have y squared and y to the 7th. Notice there's only 2 y's on top, but 7 on the bottom. When I cancel those 2 y's cancel, all my extra y's are left on the bottom. So it's going to be y to the 5th, but the 5 goes on the bottom. So there's my answer. You try the other 2 in this section. Now we'll look at the 0 exponent. Anytime you have something with 0 as the exponent, that term just equals 1. You can see why that's the case when we look at 8 squared divided by 8 squared. 8 squared is 64. 64 over 64 is 1. But if I do it with subtracting those exponents, I get 8 to the 0 power. So that's why anything to the 0 power is just a 1. So for example, if I have 4x to the 0 minus 9 plus y to the 0. Well, this x to the 0 is just a 1. So I have 4 times 1. Minus 9. This y to the 0 is just a 1 plus 1. So I have 4 minus 9 plus 1, which is negative 4. You try the other 2. Sometimes you will see a negative exponent. Anytime you see a negative exponent, notice what happens. We had a to the negative n power. That a moved to the other side of the fraction. This was over 1. The a to the n moved to the bottom of the fraction, but it also changed to a positive n. Whenever you move it, it changes to a positive n, or a positive exponent. If I have 3 over x to the negative 1, I have a negative exponent, so I'm going to take that term to the other side of the fraction. It's going to go up top. And when I move it, it's going to become a positive one. So I get 3 times x to the first power. There's still a 1 in this denominator because everything is multiplied by that invisible 1. So I could write that over 1. But normally I just write, if 1 is the denominator, I would just write that as 3x. So you can see here, negative exponent, move the term to the other side of the fraction and make it positive. Why would we do that? B to the 2nd over b to the 5th. That means b times b. And then in the denominator, I have 5 b's being multiplied. More of them are in the denominator than in the numerator, so my leftover b's are going to be in the denominator, and there's 3 of them, b to the 3rd. There's no b's left in the numerator, but remember, I can always multiply everything times 1. There's that invisible 1 up there. So I put 1 over b to the 3rd. If you do the subtraction method, we would get 2 minus 5. which would be b to the negative third. But we know that that is 1 over b to the third. I'll do this example for you. Remember, if it's not a fraction, you can make it a fraction by putting it over 1. I have a negative 2 as an exponent, so I'm going to take this entire term and move it to the other side of the fraction. So down at the bottom, I'm going to have negative 5 squared. It's not negative anymore when you move it. I still have a 1 left up top because there's always that invisible 1 up there being multiplied times anything that's up there. Then I want to simplify that. What is negative 5 squared? Negative 5 times negative 5 is a positive 25. So my answer is 1 over 25. You try the other two. When you raise a power to a power, you just multiply exponents. And the reason for that is if I had m to the second raised to the second, that means I'm gonna take m to the second, the part in the parentheses, and multiply it times itself. But now I have to add those together and get m to the fourth. So essentially, I've got two groups of 2m's. So we just multiply those. So I'll do this example in the middle. I have a power, a to the negative 6, but it's raised to another power out here. So I'm going to multiply negative 6 times 2, which is negative 12. You should never leave a negative exponent. That's not simplified form. So now I'm going to move that over to the denominator of my fraction. It becomes a positive 12. And I'm going to put a 1 up here because I have that 1 being multiplied times the a to the negative 12. You try the other two examples. The last two rules, power of a product and power of a quotient, are kind of like distribution. If I have a times b, notice we're multiplying in there, to the m power, I can put that exponent on the a and on the b. Both of those are being raised to the m power. Thing to be careful about with this is do not try this if the terms inside the parentheses are being added. You only use this rule when the terms are being multiplied. So for example, if I had a plus b to the m power, that does not equal a to the m plus b to the m. No, no, no. Do not do that. I see a lot of students making that mistake. I'll do the example in the middle here for you. So I have an exponent of negative 2, and it's going to go on all the terms inside. Notice everything's being multiplied. There's no adding or subtracting going on inside here. So I want to figure out what's the exponent. If there's no exponent written, it's a 1. X is to the first, and y is to the negative second. So now I'm going to multiply. Negative 2 times 1 gives me 7 to the negative 2 power. Negative 2 times 1 again here gives me x to the negative 2 power. And negative 2 times negative 2 on this one gives me y to the positive 4. We still need to simplify that. So negative 7, so 7 to the negative 2, I'm going to put that in the denominator and make it a positive 2. X to the negative 2, again, I'm going to move that to the denominator, make it a positive 2. Y is to the 4th, so it can stay in the numerator. The last thing, anytime you have a number with an exponent like that, you want to figure out, well, what is that? 7 squared. 7 times 7 is 49. So I'm going to have 49x squared down here, and y to the 4th still stays up there. You try the other two. And the power of a quotient rule is very similar. If I have an exponent outside the parentheses when I'm dividing inside, both the numerator and the denominator get that exponent. I'll do this one for you. So remember, every number that doesn't have an exponent written is to the first power. So I am multiplying 3 times both exponents in the numerator and 3 times the exponent in the denominator. So I have 1 times 3, give me 3 to the 3rd power. Then I have my a, and that's negative 4 times 3, which is negative 12. Down in the denominator, I have 3 times 7, so that's b to the 21st power. Now I want to simplify anything I can simplify. 3 to the 3rd power means 3 times 3 times 3, which is 27. A to the negative 12th power means that I need to move it to the other side of the fraction, down to the denominator, a, and then the 12 becomes positive. And the b to the 21st just stays down there. I'm going to just center that a little better, and that's it. You try the other 3, and then turn it in when you're done. Hope you have a great day.